So this video is about applications of law of sines. So we're going to be using our normal ratios that we have to solve applications. So the path of a satellite orbiting the Earth causes it to pass directly over the two tracking stations A and B, which are 50 miles apart. So we can mark that. They are 50 miles apart. When the satellite is on one side of the two stations, so just like this picture, the angles of elevation of A and B are 87 degrees and 84.2 respectively. And you can look at them and see that the one on the left has to be taller than the other one. So we can mark them this way. So if you remember with our law of sines, the first thing we want to do is fill in that triangle. So let's redraw our triangle so that we have just what we're looking for. So this is 84.2. This is 50. It's degrees. And then if you know that's 87, then this would have to be 93 degrees because 180 minus 87 is 93 degrees. So that would be 93 degrees. And then now we use the exact same thing as 180, take away these two to find that missing angle. So what's 180 minus 93 minus 84.2 equals 2.8. So now we have found them all, and I like to mark it. I'm going to call this A and this B because that's what they gave me, and then that's C. So this would be little a, little b, and then we know C is 50. And so we always want to gravitate towards that given side and angle that are mixed together. So we know that sine of 2.8 is the same as, is to 50 as, and then we just pick one that we need. So it says how far is the satellite from station A. So to go from C to A would be our distance. So what we are looking for is B. So we will do sine of 84.2 over B. And there we go. So again, B goes over here, right? And so it's B sine of 2.8. And you're probably already good at this where you can just rewrite it. But I'm going to take my time here. So we get 50 sine of 84.2 divided by sine of 2.8. Plugging that in our calculator gives us 1,018, and this is miles. So it's miles. So this satellite is 1,018 miles from A, from here to here. Okay, next question is how high is the satellite above the ground? So you may be thinking that we're going to be using that same triangle. Oh, that's a horrible picture. Let's try this again. A little bit more perspective. Like that. We call this A, and this is B, and we were given that as 87. But what it is we're looking for the height here. So you can see why I just drew the 87. This is what we have here. So what we're given here is actually a right triangle. So let's draw our triangle that we're given. We're looking for this height, and that's 87 degrees. That's 90. That's 50. And so do we need to use law of sines? Can you? Yes. Do you need to? No. This is just a plain old tangent. Tangent of 87 degrees is equal to h over 50. You don't want to forget our basic trig ratios. They're very important. And so when you see that 90 degree that's stuck in there, as soon as they say an altitude and you hear the word perpendicular, you know you get to go back to our standard trig ratio. So 50 tangent of 87 degrees is equal to h. Right? So h is tangent 87 is h over 50. And if we plug that in our calculator, we get 954 miles. So how high up is the satellite? It's 954 miles. So we use law of sines when it's not a right triangle. But if you're given a right triangle, then you just use your standard trig ratios. All right, let's try one more. So to find the height of the building in San Francisco, this guy right here, you stand at the tip of the building's shadow, 215 feet away from the building, and find that the angle of inclination of the street is 22 degrees. You also measure the angle of elevation of the sun is 52 degrees. Find the height of the building. Okay, so this one is going to give you a little bit there. The triangle that we want to find first is what we're looking for. So it got cut off a bit. Our street's angle of inclination comes down here, and then the sun's, and this is all shadow in there. I'm not going to even draw it, but the shadow comes back to here. So that means this location from here to here, that's our 215 feet. And this street has, remember, everything is going to be with the horizontal when they give you angles. So the angle inclination of the street is 22 degrees. And the elevation of the sun has to be with the horizontal is 52 degrees. So using that, you know that what we're left here, this has to be 30 degrees because 30 plus 22 equals 52. And so why am I using that? Well, that's our triangle right here. Because what we're looking for is the height of the building. And so the triangle that includes the height of the building is that one. So let's retrace it over here. Vertical. And then back down. Just has to be a rough sketch, nothing perfect. And then we fill it in. H 215. Okay, not enough info. So in order to use law of sines, we have sine of 30 is to h. Great, we got that one. So sine of 30 degrees is to h as something is to 215. So we need to find this angle here. This is the angle that we need to find in order that we can use the 215. So we have sine of something. So the angle opposite 215. Well, that goes back to using that 52. So why they gave us this 52 is because there's another triangle sitting there. So you may not see it, but it's this one. It is actually a nice right triangle. All buildings are supposed to be perpendicular. They should be, or they fall over. So there should be a 90-degree angle right here, which means there's a 90-degree angle here. So I'm going to take that triangle and just trace it over here so that we have a quick picture of it. That's 90. That's 52 degrees. And so you can see now that what we're left with is 90, 52. So that has to be, you guessed it, 38 degrees because 90 take away 52, right, is 38 right there. So 38 degrees. And so the reason that one's important is it's this one. And that's this one that we have. So that's 38 degrees. That's 38 degrees. We now have everything we need. So if I plug in 38 degrees there, we can do our quick little multiply. So we get h equals 215 sine of 30 degrees over sine of 38 degrees, right? Our cross multiply. So this times this divided by this. It's all perfect. And then we plug it in our calculator. And then we get h equals 174.6. And our units are in feet. So this is a very complicated way to figure out the height without going online and looking it up. But it's 174.6 feet. I think it's much more fun to do it this way. But yeah, you got to get out there and use this little inclimeter to figure out what the angle of incline is for each of these. But that's it. So on each of these, you're trying to create that triangle. And you've got to have an angle and a side at least to start. One angle, one side. And you can use law of sines then to find the other angle or the other side for each of these. But we need that triangle. Thank you.